blue. Everybody should be thinking about this question. Did everybody hear his question? In the back? Okay.
Well, the sides are rectangular. The other faces are rectangular. So the base gives the name.
Yes. But the question is, how did you know that the pentagons are the bases? That's what he's trying to
Well,
get you to get.
because I thought it was because when you split it up, it would be taller. It would be sitting. That's,
It's taller, but how are the shapes now orientated?
well, the pentagons are opposite each other, like at the two ends.
So they are, what's the word for that? Opposite each other?
Faces, lateral faces.
I'm sure. They are parallel, so the bases have to be parallel. Those two pentagons are parallel. Those rectangular lateral faces, no matter how you turned that, which is what he was heading for, would not be parallel. So the pentagons have to be the bases. I mean,
Would it be okay to say if you were making cookies, you want to have the exact same cookies cut? So if you had that pentagon, you would have pentagon cookies all throughout. If you turned it the other way and cut it, you would have odd shaped cookies. Does that make sense?
you could, but that would also work with a pyramid. If you have a pentagonal pyramid. Be careful, yes ma'am.
So why do we see it laying like that versus standing up? Is it because they're limited or anything?
That's a good question. Why is that like that? Because when I copied and pasted that, I could have turned it any way I wanted. I can still turn it any way I want if I wanted to go over and turn it.
You always see it like that though. I've never seen it stand like
Can you understand it? So what difference does it make how it's standing? Oh wait, I grouped them, so never mind.
Just ungroup it.
Just right click over.
Hang on, I hear people answering and I haven't called on anybody.
Oh,
I have to get my wet noodle out and do some spanking. Okay, so Catherine? Yes, Catherine.
Yes.
Does the orientation make a difference in which sides are the bases? That's the important question. Oh, good job.
I think it's easier.
Which sides are the bases?
Does it make a difference how it's turned? Does it change the bases according to how it's turned?
No.
Why
To me.
not?
To me, no, because I know the answer. But, because we've already talked about it, but because you still see, you just see it in a different way. I guess what gives it away for me is the rectangular shapes of the sides.
The lateral faces.
The lateral faces. You see them this way, and it indicates to me that there's still another one because of the way the blue is shaped. So there's got to be another one here and another one here. Even though I'm looking at it from the top part. So I know that there's going to be another side of the blue on the other side of the rectangles.
Okay, you said another side on the blue of the other side. Could you be more specific?
I'm sorry. On one side, I see the blue, the first face. All right?
Would you like to come up here and point? I want everybody to be clear, but we have to know this before we can go back to science.
I'm thinking I'm looking at this from the top of the prism.
Okay.
And so because I see these two sides right here and I see the blue, I know that there is another rectangular side, lateral side on this one and this one. So I know that this one, this blue face has another blue face on the other side.
That is congruent and parallel?
Right.
All right, so those are the bases, even though it's like this, but if I lay it down on the green, would those two blue sides still be the bases?
I would still, I think, I would see it, it would just be a little different angle.
Yes, because they are
Parallel.
It. Fill in the blank. What makes those, thank you, what makes those still the bases? Yes, ma'am.
Well,
to ask the question, it's like, okay, we turned it, did any of the properties change?
Good question.
Did point, did this edge, did it change?
Okay.
Or did I get more pentagonal faces whenever I turned it? Do I have less rectangular faces whenever I turned it? So no matter how I do it, it's still, none of the properties have changed, it's just rotated.
Okay, so none of the attributes have changed.
We're still on how do we know what's the base of it? Looking at this from a mathematical standpoint and understanding what the formula is of a prism, then I understand that in order to solve volumes for things like this, I have to use the base and use that to multiply it to stretch it up, like filling a glass of water.
To layer.
To layer it up. If I layered it when it's on its rectangular side, it's just gonna form a bigger rectangle. It's not gonna go out and create those shapes. But if I create it on its base, which would be the pentagon, or pentagram,
Okay, yeah, Pentagon, you're right.
pentagon, and I start stacking it, it will begin to create this shape. So by putting it on its base, meaning that the bottom and the top have to be identical, when I begin to fill it, it will form that shape. If I fill it while it's on the rectangular side, it will just make a rectangle.
To go off.
Yes, ma'am?
I have a question. I thought there was some more. So a rectangular prism, how would that definition have to change?
We'll get there in a minute.
Okay.
Yes, ma'am?
I don't know if this, I'm thinking if I'm a child in the classroom, so are you saying that the base have to be similar to the tops for me to figure it out? What about the other figures, cone,
We're not
the
there yet.
base? Okay.
Yeah, we're gonna get there. For a prism has to have two bases, and they have to be parallel and congruent. If they don't have two bases that are parallel and congruent, it's not a prism. Which brings us to, yes, ma'am?
To go off the image, to go off the prisms, we talking about the water, but for those more visual, fill it with like Play-Doh.
So that was right. You put layers of Play-Doh.
And then when you take it out, they can see what that, once it's filled, how it makes it form.
Okay, so if she filled it with Play-Doh, layers of Play-Doh, then they could remove the original one and they could see that, which is why we bought you, Brenda, is that yours? Would you hold up a prism that's in there? Which is why we bought you these, because the yellow part can be taken out. And that's the net. And you can talk about surface area on those and then volume in the clear plastic part. So going back to, going back to a pyramid now. Okay? Pyramids are also three-dimensional shapes. According to the definition, it has one polygonal base and the lateral faces are triangular. Alright? So if it has two bases, it can't be a pyramid. And pyramids have to have one base. What shape can that one base be? Any polygon. Any polygon. What shape can it not be? Wait a minute, let me get back to my names. Let me get back to my names. Greg. I'll skip you.
Thank you. I knew the answer.
Hang on a minute, I'll find somebody I haven't done.
I'm visually
Kim.
challenged from this distance.
Circle.
Why can't it be a circle?
I don't know. I just heard her say it.
Cannot be a circle. Is a circle a polygon?
Made up of line segments, right?
Thank you. Polygons have to be made up of line segments, and I'm not in very core questioning strategies because I asked the question and all of you answered. That's called core response. Not good, right? Okay. So the base of a pyramid cannot be circular because a circle is not a polygon. A polygon has to be made up of line segments. And in mathematics, line segments are straight. Line segments are not curved. We call curved things curves. And they are not line segments. Lines, I know in other disciplines, lines can be curvy, but in math, they're straight. All right, so pyramids have one base of any shape as long as it's not a circle. Cylinder, how many bases, and looking at the picture, how many bases does a cylinder have? Let me get my names. Thank you for being quiet. Jennifer? Yeah. Two. And what shape are those two bases?
Circular.
Circular. What do we call the rest of it?
Lateral surface.
The lateral surface. Is the lateral surface a polygon?
Yes.
No.
Dang it.
Hang on.
Then a net.
Tim?
When,
Yeah.
as it sits in
Tim
a
is talking.
cylinder, no, it's not because it has no edges.
Okay.
But if you were to take it and unfold it, the lateral surface would then form a rectangle, which does have.
It appears to be a rectangle. Brenda, can you pull out the cylinder, please, and hold up the net to it? You were all supposed to bring those, but.
I have mine image coming up.
Okay, good. So you can see the two bases clearly are circular, and the lateral surface, which is a curved surface, if you lay out the net, it appears to be rectangular. Okay, thank you, Brenda. And then we have a cone. How many bases does a cone have? One base. That was bad, because that was a poor response. Craig hit me every time I did that. Melissa, what shape is the base of a cone? Where's Melissa? It's a circle. Is it polygon? Why not?
Because it's not made up of lines.
Very nicely done. So, Carla. We have a Carla? Nope. So, Rochelle, tell me about everything you know about a sphere.
Everything.
Everything.
Not a polygon.
It is not a polygon because you have to rationalize it.
Okay, because it has no flat faces or no line segments,
Good,
no bases.
good. Okay, so it's not a polygon. Polygons, by the way, are two-dimensional. Okay, so it's not a polygon. It's also not a polyhedron. Because polyhedrons, that's what you were trying to define.
No faces.
No faces, which are flat, no line segments, no edges. Okay. So how do we get a sphere? How is a sphere created? Let me get my names. Brenna is the winner.
If you were to like make it out of Play-Doh and put a stick through it, it'd be equally separated anywhere you stuck it through, right?
Okay, so you're almost there. So it's the set of all points, the same distance from a point called the center, which is what she was trying to tell us with the same distance across. She was talking about the diameter, or maybe a radius. So if you have this point in space, right here, and you have all the points that are 6 inches away from that, you would have a sphere. Okay? All right, yes, sir.
You had a circle rotated, spun it with
Excellent question. So let's picture that in our mind, okay? We have a circle, and circles are flat, so they have no height. So let's pretend that we have a circle with height, all right? Let's suppose it's like 1 inch tall. Circle about 1 inch tall. What would that really be? Please raise your hand. Yes, ma'am. That would be a cylinder. That would be a cylinder. Yes, ma'am.
Well, maybe if it's a flat, but you like spun it around, is that kind of
That's
what you meant?
Like one of those gyros?
Yeah, like,
If
yeah.
a penny
And
is
then
split
like
a penny,
form.
that would make the sphere.
Okay. Would that make a sphere?
Yes.
Who says yes? Who says no?
A what, a penny?
You spun the penny, would be a sphere.
Tell me why not, Martin.
Because it still wouldn't, at any point in time, it wouldn't consist of all the points distant from the center. It'll always only have one sliver of that at any point in time on the side.
Okay, so it would not contain all the points the same distance from the center. Is that what you were thinking, Craig?
Okay, so yeah, if you stop it, yeah, it's still gonna be a penny. But if you could like have all those, the path that the penny took, like say you painted it around,
Yeah.
like, and got that shape, that would be a sphere.
So if you could map all of the points that the penny did as it went around, then you agree? It would be very nice. Y'all are just so good. Okay, so just a little bit about volume, and I don't have to say much about this because Martin explained it very well a while ago. In volume, it's really the capacity of a container, or sometimes it's the size of an object. Some people will say the amount of space the object holds. There's lots of different ways to define volume. I couldn't find one that I really liked that was really formal, so those are very informal definitions. And it's found by layering. So pretend these are cubes. These are cubes in your mind. So what would the volume of that triangular, rectangular prism be? Hang on. I got it. Elizabeth. Those are cubes. Those are centimeter cubes. What is the volume of this rectangular prism? That would be a rectangular prism.
The volume of the centimeter cube would be length and width and height.
Don't use the formula, sure.
Oh, okay.
Just visually.
Length, width, and height. That way, huh?
Just visually. These are centimeter cubes. How many do you have? 3. So what is the volume of this rectangular prism?
Oh, 3.
3 what?
Centimeters cube.
Good. 3 cubic centimeters. Now if we layer that, Martin, now what is the volume?
6 centimeters.
Good. 6 cubic centimeters. And if we put another layer, Cora, what is the volume?
9 cubic centimeters.
I lost you. 9 cubic centimeters. Very nice. So once the kids understand, as Martin was saying earlier, that volume is found by layering, then we can go to the volume formula, which is area of the base times the height. So we have the area of the base, which was 3 cubic centimeters, times 3 layers. You give us 9 cubic centimeters. For rectangular prisms, it's a different volume formula for other figures than for rectangular prisms. All right, so you're up.
We need a quick break.
I think that's a great idea. It is 10:35, 2 minutes, take a lap.
Even you can lay on the side, I think now that's a base. And you can, every side can be a base.
It can be a rectangular prism, but it cannot be a cube.
Right.
Because you can lay it down, because the top and the bottom have to be the same.
Because if you try to this way, you're not gonna have to distinguish it.
And the top and the bottom have to be the same. Yeah, it is, but these are not parallel. These are parallel. But see this, it can still go parallel. Still go parallel.
There is one here.
Still go parallel. This one should always is parallel. This is never parallel. This is always. Because it is. But if this was a little off, it could be, it's square for this.
I really appreciate you coming, even though.
This one, every side's a base, every side's a face. But this one is only this one.
These are the square is a rectangle.
As long as it's easier.
Because if it's a square prism, then
Yeah,
this will
my-
only be able to stand this way.
Who is actually that, the other half person, you know, the other half of the opening night, we use our program, school, and you feel when we're trying to see the other bus.
Because you're not gonna have it. So this one.
Then I didn't
this
need to
is
work
a
somewhere,
square
because
prism.
I'm not.
This is a rectangle.
Would it be called less, could it be called a square prism?
You're calling these to the bases? Yes. So, can they be the bases? How do you?
Easily congruent and it has the parallel
So these can be the bases. So that basis what kind?
And you can't miss it.
Rectangular prism. But in this one, She went because there was.
It's great, and it was hardcore.
Could it be this way? Yes.
Andrea, our drawing one, I can hear from my house.
Oh, yeah.
And I live there about 3 miles.
You live here.
I live about 3 miles.
Say that word, say the magic word. They're congruent and
Living here.
congruent and extreme. So these could be the.
I just think it would be a problem if you can hear me and she would use it, never like it great.
This is the.
Not that I don't think she deserves it, I think she's an excellent. She has before. Oh, she has? Oh, okay. I just think like coming in. Move the drum one. I actually want to be in her position. Like I don't even like being in my position.
Did you know? Hey guys, we're gonna go ahead and get started. Those of y'all that are in here, we're gonna do an investigation. So let's spend a few minutes really cleaning off the tables and putting things away that are not essential that we need. You need a pen or pencil and your lab notebook.
Caffeine upstairs. I've got a 10.
Gonna take bills?
What's that?
You take bills?
Yeah, I guess, but I don't have any left. I'm not worried about it. What's that?
Coffee.
Huh?
Seriously, where's the coffee?
There's no coffee up there, is there?
Oh, soda.
Cover.
Soda.
I'm good now.
You're lucky. That's the only one I had. I don't have any ones either, which is a good problem when you have money and they're not ones.
Yeah.
There's a watermelon in the grape, but it's relative to the water.
We went up there and dropped Sophie off at Notre Dame, and then we went up to Michigan to bed and breakfast for a few days for the anniversary. And we came back and we spent the night in Chicago. It's by Southwest.
Chicago is.
Ah,
My one experience when Erin was a senior in India, she had an internship in D.C. Over the Christmas break, we drove her up, and I took a couple of days when we came. I was 15, and we took a couple of days at the beginning of the second semester and came back. We had the computer virus. I came in, and I was because I'm way up there, and they're all, and those knotheads from technology came over and started wiping everybody's computers, teachers were losing everything. It was like,